Hello, in this video we will be covering the pocket demo, the boss demo, and the hole demo parts. Right now I have opened the pocket demo. This is what we'll be using first. If you haven't already, open the add-in Camworks by simply going to Tools and Add-ins. Once you've done that, you can simply go to the NC Manager, and what we'll do is we're going to extract machinable features. Now, if you remember before, we learned how to manually add in features, but usually Camworks does a pretty good job of recognizing features and putting them in for us. So we're going to hit Extract Machinable Features and see what Camworks gives us. So what it has done is it has looked at this hole and it determined that it is a drill. And it should have a drill bit that can simply drill out this hole. Now we're going to look closely at this hole for a second. I'm going to go to Evaluate and just simply measure how big this hole is. And I can see it's a 1.5 inch diameter hole. That's a pretty big drill bit. That's a drill bit that you're not likely to find, and even if you are able to find a drill bit that large, it's not going to produce a very accurate hole. The other thing we can very carefully see, if I simply section the view, is we can see that the bottom of this is a right angle. Most drill bits have angled tip to aid in them drilling a centered hole. Because of that, most of them can't do a right angle bottomed hole. So going back, we can clearly see that a hole is not the feature that we want to use. So I'm just going to delete this. It'll ask me if I want to. Yes, I do. And it can go into the recycle bin. This sort of is a nice feature of Camworks. Every feature, every operation that you define gets saved in this recycle bin. You can remove them from the recycle bin, in which case you'll never see them again, or you can restore. This is helpful because sometimes when you're doing things, you may remove something that you later on choose to get back. This means that you can just look into the recycle bin and get it. But going back, what we want to do is we want to just pocket out this hole with a smaller end mill, starting in the middle and just pocketing it out and taking it down step by step. This is a general way to machine. So, but I've gotten ahead of myself, for those of you who may or may not have realized. So what I'm going to do is I'm going to go back and we're going to see what I haven't done yet. So going back to our process, I have not checked the machine, and I have not checked the stock. I just jumped straight to machinable features. This is a dangerous practice, and this is not something you should do because you can make mistakes, especially with this machine change and controller parameters. So before we go any further, what we're going to do is we're going to check the machine. I want to use mil-inch, like we've been using. I was using millimeter, and I want to use crib 4. So we're going to select, and that should be much better. The next thing is for the stock. Now, in the previous video, we saw in a part perimeter and face feature that we used a little bit of an overhang. Oftentimes what you'll find is you have previously machined a block to size before you cut out more detailed features such as pockets or bosses or holes. So we're going to assume that whoever's making this part already has a correctly sized blank for this, and all they have to do is simply machine out this pocket. So we're going to be okay with the minimum bounding box, and we're going to move on. So the next thing we have, what we can see is by clicking the Extract Machinable Features, it added this mill part setup 1, and it's centered around this hole, and it is on the top of the part. This is a good setup. We can work with this. But let's say, for instance, you missed the beginning of the video and you didn't click Extract Machinable Features. by adding, you can manually add a mill part setup by right-clicking Stock Manager and clicking New Mill Part Setup. We did that in the last video. It's the same in this, but we already have one, so we're going to add a new 2.5 axis feature. Now to do this, what we can see is we're not doing a face feature, we're going to do a pocket. And now we can select a few different entities. So we could select this contour, we could select this face, we could maybe even go in and select specific sketches. To be easy, I'm just going to select the bottom face. Whenever you're doing a new type of feature, there's a variety of things you can select. So sometimes it's a little bit of a hit and miss, and you just sort of have to guess, make sure that it comes up and you're able to select it. If you are, it will come up here. If you're not, then it won't come up here and you won't be able to select it. Another thing worth noting is right now we're defining a single feature. If you have a pattern of holes or a pattern of pockets, you can define multiple features and select all of them at the same time, and it'll give them all the same parameters. This can be a useful tool if you have a lot of similar features in the same part. Going to next, we can see that right now it's starting off of this bottom surface, and it's wondering what the end condition is. You can see that there's this sort of green cylinder of material. This is the material that Camworks is considering as removable material. It's stuff that Camworks is going to take out. And right now it says we're extruding it, and we can see we can extrude it more or less. Well, this doesn't seem like a very smart way to do it. It seems like we would want to extrude as much just to, relative to the part, so that if the hole got deeper, the extrusion would get deeper. So just like any extrusion, we can change the end condition, and we can go up to face and do this top face. Now we can see that we're defining exactly the amount of material we need to cut out, no more, no less. Next is strategy. We can see, is this through the entire part? It is not. And we can see a rough finish, coarse, and fine. Let's leave rough finish. We've already seen sort of what coarse and fine do. They just generate this one contour, if you've been paying attention. There's no islands in here, so if we hit next, we don't have to define any islands or anything along those lines. So we can just hit finish, and it automatically asks us if we want to bring in any additional features. We do not, so we can close. And now we have this circular pocket feature. If we generate operation plan, we can see that this one feature has generated 2 different operations. So what we're going to do is we're just going to generate the toolpath and see what these operations are. So I've generated toolpath, and we can see we've got one operation. It goes around, then another operation that goes around a little bit wider. We have one that uses a 0.88 flat end mill and a 0.56 flat end mill. 0.88 is a very large flat end mill, and it's something that you may or may not be able to find in your shop. This is important because if you can't find it in your shop, then what you'll have to do is you'll have to select a tool that you do have in your shop. But for now, we'll assume that you would have this, you have a well-supplied shop that is stocked with all the tools you need. So we're going to simulate this toolpath and sort of see what's going on. Slowing it down just a little bit, we can see that it's cutting. And I'm just going to pause it right here, and I'm going to click this compare button. And we can see that while we definitely have more material to remove from the bottom, we can also see that the sides are slightly blue. So that means we still have to cut a little more material on the sides. So going back, I'm going to uncheck the compare to for sake of speed, continue to run it. And now what I'm going to do is I'm going to pause it. And we can see that it's just cutting a little bit more material, and we can see that this is sort of a finished pass where we're just cutting a small amount of material just to get the part exactly the size. This is a very common machining practice. You take a lot of the material out. Sometimes what happens is tools can be under high load or high stress. They can bend and flex, and they won't cut as accurately. Whereas cutting a very small amount of material, tools generally hold their shape better and cut much more accurately. So we can see that by letting this finish, this is going to completely and perfectly cut out our part in the simulation. And this looks good. We can see that a step relative to our end mill size is reasonable. Our smaller end mill is stepping down more often because it can't step down as far because it's smaller. The general rule of thumb is something along the lines of half of your diameter. So we can see that this is coming down maybe 0.4 inches at a time, whereas the smaller end mill may be only coming down 1/4 of an inch at a time. And this it seems reasonable. Going in, what we're going to do is we're going to edit the definition of the rough end mill just to see what we can. We have the same tool tab. We're happy with that. Same feed rates and speeds. Right now it's defined by a library. We can overwrite it by clicking Operation. Overwriting tool speeds and feeds, you should always ask your instructor or whoever's managing the machine that you're using to ensure that you're going at an appropriate speed for what you're doing. Be sure to be knowledgeable about how fast you are currently thinking you're going, as well as how much you're cutting, in other words, depth of cut and step over, and how you're holding your part. Because if you're not holding your part down as much, you can't cut as aggressively. Going to the next tab, you have roughing. We can see right now we're cutting about 40% of the diameter of the tool, or 0.35 inches. Again, that's just switching between percentage. We have a cleanup pass. We're staying at the depth, and we're machining any island tops, although there are no island tops. And we're operating at a 40% step over. And we're leaving this 0.01 inch side parameter allowance. This is how much we're letting so that the finish pass can finish it up. Because again, these are two different operations operating on the same machinable feature. So if we set this down to 0, the second operation would essentially do nothing. Or conversely, and this is what I'll have you do, if you set this to 0.1, the second operation is going to be cutting significantly more material. Next up is the NC plane. We already discussed these in the last video, just defining what the rapid planes and the clearance planes are. These should be the same for all of your parts, for all of your operations. We can see the machining depth as well as the entry and retract methods, whether we're plunging, drilling, or going in a spiral down. We can see the limits or do some more advanced avoid or contain areas. Some posting information, and we can see that this particular operation seems to be estimated to take about 4.5 minutes. So we're going to hit OK. Remember, we changed that one thing, which was that side allowance. We can see that the circles have shrunk. Going into the contour mill, so this is a rough mill and a contour mill. They're very, very similar, but we're going to edit the definitions. We're happy with the tool. Feeds and speeds, always check with the manager of what machine you're working on. This is very similar to rough mill. We can define our side parameters. We can define our depth amounts. And notice there's no step over because this is just doing a simple contour rather than a pocketing out scheme. We have our rapid planes and our clearance planes. In this case, the rapid plane is 1 inch, whereas before it was 5. So we'll change that. And the clearance plane is 0.1 inches, where before it was 1. Feature options, we can see machining depth as well as entry and retracting methods, just as before. We can see specific lead-in structures. We can do different types of lead-ins. Looking at this screen, an arc, we can see detailed information, perpendicular or parallel. You can play around with those. We're going to stick with none for now. As well as advanced, posting, and optimize. This is looking to take a little under a minute. This is a little unreasonable. 30 inches a minute is quite a lot. But we're going to hit OK. We're going to simulate it. And that seems good to me. So the last thing we do is we post the post-processor code, but because we're not actually machining it, we don't have to right now. Moving on to the next part, it's going to be a very similar part. It's going to be the boss demo. It's going to look something along the lines of like this. So for this, what we're going to do, first things first, going back to our flow chart. We model the part. We change to the Camworks feature tree and add in Camworks if we have to. But first things we have to do, we define the machine and define the stock. In the previous part, we defined Machinable features, generated an operation plan, adjusted the operation plan, generated toolpath simulate, looped around once to make sure it was correct, and we stopped at post-processing. In this next one, what we need to do is we need to check the machine. Machine's going to be mill inch. Tool crib's going to be crib 4. We're going to hit OK. Check the stock. Again, double clicking. We're going to say the material is, let's say, 6061. Bounding box is OK. And now we'll try to add machinable features. First thing we do, just simply out of ease, is we will do the extract machinable features and see what it comes up with. So what this has done is this has done an open pocket. This is very similar to a boss, and you can see that it is actually selecting the right amount of material, the right material to cut away. And so this is technically correct, but what we want to do is I want to show you a boss. So we're going to delete this feature. Now again, we're using the same mill part setup. If we didn't want to select extract machinable features, we could simply right-click the stock manager and add a new mill part setup where we choose. But we're happy with this, so we're going to add new 2.5 axes feature, and we're going to do a boss. And we're going to select this outer edge. It's a single boss, and we're going to click next. Blind. Well, we don't want to do blind. We want to have intelligence with how we design this. So we're going to go up to this next face. And we're going to have a strategy of fine. Next we have finish. So what this is going to do, we're going to close. We don't want to add another feature. And we're going to see what this circular boss is going to do for us. So we're going to generate the operation plan. And we see this contour mill. And we're going to generate toolpath and see what that looks like. So what this is doing, this isn't actually what we wanted. We didn't want all of this. And actually what we wanted was an open pocket. And what we'll do after this is I'll show you the difference between them. But for now, we're going to simulate the toolpath. So clearly, we've cut around our boss very well, but we didn't cut any of this extra material. That's because when you select a boss as a feature, you're really only selecting the outside edge of the boss. You're not selecting all the other material you want to step in. And that's somewhat the fundamental difference between what a pocket is versus what a profile is. A boss is more of a profiled move, whereas a pocket, what a pocket does is it takes an area and has you machine out all of the area inside. So what we're going to do is we're actually going to go back and we're going to go into our recycle bin and we're going to restore this. And now we're going to generate operation plan. We're just going to update it. We don't want to regenerate what we've already done. And now we can see that there's a contour mill for this first pocket, and then there's a rough and a contour mill for the second pocket. So we're just going to generate toolpath for those. And we can see that the rough mill sort of steps in and gets rid of all that extra material, and then the contour mill just cleans up the very last pass. All right. Now, right now we can see that this contour mill and this contour mill are essentially the same thing. So we have a couple of options. We can simply suppress one of these, delete one of them. We could do either one. So right now we're just going to suppress this first one. And we're going to simulate the toolpath and see what a difference the open pocket makes instead of the circular boss. So we're going to simulate, click play, and we see that machined it very well. But before we finish, we want to make sure we check the operation parameters. So we're going to edit the definition of the rough mill. We're happy with this tool. It seems like a reasonable tool. We check our feeds and speeds, and remember, you always check with the manager of whatever machine you're running on to make sure that your speeds and feeds are appropriate for your application. Going to the roughing, we can see we have a certain amount of cutting in Z. We're leaving an amount of allowance for the contouring application, and we have a certain step over, and we can change these as we want. So I'm going to increase this step over to be about 60%. This means it's going to take less cuts to finish this. Switching to NC, we have a rapid plane and a clearance plane. We've got our machining depth, which is defined already for us, as well as our entry and retracting points. We have our limits, posting options, and estimation of how much time it is and the total tool length. We hit OK. We can see that now we're stepping over a larger percent. It's going to make it go a little bit faster, and it's going to make it cut a little bit more, which means it's going to be a little bit harder on the part and the tool. Next, always check the contour mill applications. Tool looks OK. We're actually using the same tool to rough as finish, which is fine. Some tools, however, are only for roughing or finishing. It's important to be aware of the nature of the tools you're using. The feed and speed, again, these need to be checked over by a professional. And you can see depth parameters. All of these seem okay. The rapid plane is different. We're going to go back to the 5 inches. I hit enter, so it sort of went across the board. But I can tell that the other parameters are almost certainly already done for us. They're reasonably good. We need the clearance plane of 1 inch, feature options, entry, retracting, machining depth, lead in, lead outs. We don't need to use them in this case, as well as upper and lower limits and posting options and the time. So we're happy with this. And again, if we're done, we can simply post-process. One last thing, we'll just simulate it. Seems good to me. So again, we've gone through, we've edited the machine, defined the stock, defined features, generate an operation plan, adjust the operation as needed, generating toolpaths, simulate toolpaths, looked at them. In this case, we actually redefined the features. So sometimes you have to go along and select new features, but in some cases you don't. And then we could post it and transmit it to the CNC. Next up, we have the hole demo. If we open that, we can see there is 5 holes. There is a plane through hole with a near side countersink. There's a countersunk hole, a counterbored hole, a threaded hole, and a blind hole. These were all created with Hole Wizard, and what you'll find is that generally Hole Wizard is pretty well recognized by Camworks. So what we're going to do is we're going to switch to the Camworks feature tree, define our machine as mill inch, define our tool crib as crib 4, and hit OK. We'll also take a look at our stock. Default is a bounding box. That'll work for us. So next we'll hit extract machinable features, and we see that it extracted all 5 holes correctly. And next what we're going to do is we're going to generate an operation plan. This is going to get, as you can see, we got a lot of operations. If we select each one, we can open it up and see what specific hole each one is referring to. And it somewhat has come into the same order as the holes were. So we can see that this countersink, this drill, and this tap are all for this threaded hole. Next up, we have a center drill and drill for this blind hole. We have a center drill, and then a contour mill for the counterbore hole, a center drill, and a countersink for our countersunk hole, and then a center drill, and a countersink for our hole with the near side countersink. Now, one of the things that you might notice is that we've got a lot of center drills here. I'm going to show you now that what you can do is you can actually combine a lot of the similar operations into one operation with the same parameters, and that way you can change parameters for all of the operations at once. So to start with, I'm going to hold Control and select all of the center drills. There should be 4. And we're going to right-click and combine operations. You can see these are the operations we're combining. We're going to copy the parameters from one to the rest, and we can select which one. Right now, we didn't really define any parameters for any of them, so it doesn't really matter. So we'll just do 1, and it'll regenerate toolpath after we combine them. So we hit OK. Now what we can see is we have this one solitary center drill. Likewise, we can find other things that use the same tool. We can see both of these countersinks use the same tool 19, a 90-degree end mill. So we can combine these operations. We have two drills that use a 1/4-inch drill, so we can combine these operations. We have 2 drills that use a 0.27-inch drill. We can combine these. And that looks to be it. Now we can see we have tool 12, tool 13, tool 14, tool 18, tool 15, tool 17, tool 19, and tool 16. So we don't have any repeats. That's good. So now what we'll do is we'll generate toolpath, and we'll see what Camworks comes up with. After that, we'll simulate the toolpath. I'm going to slow it down a little bit, and we'll just see what it's going to do. So to start with, it is countersinking the tapped hole, and now it is drilling the tapped hole, and now it's tapping the tapped hole. Next up, it is milling out the counterbore for the counterbored hole. Now, if you're thinking it would make a lot more sense to center drill the counterbored hole before you bore out the bore, you're absolutely right. And what we should do is we really should center drill all of these holes first. That would be the most prudent thing to do. As you can see, it came down on that counterbored hole and it didn't even cut the part. So after this finishes, and actually what we'll do is I'm just going to close out the simulation. I'm going to show you that to make it so that we center drill first, I can just simply click and drag up to the top. And now what we'll do, we'll simulate again, and we can see now we are center drilling the 4 holes and then countersinking the 5th one before we do anything else. This is the most intelligent way to approach this process. So, and this goes for not just drills, but for all operations. We can reorder contour mills or combine different contour mills very easily. So if you've got a part with a lot of different profiles, and you want to have the same behavior of the tool, you want to cut them in the same cutting steps at the same feed rates and speeds, with the same step over and allowances, and all those different operation parameters, then you can very easily combine them, and then you only have to modify them one time. Also, you can click, drag, and drop and reorder any contours if perhaps you want to cut out a part at the very end, but you want to do all the detail work before you cut it out, because then it'll become loose in your fixture. That's very easy to do. You can just simply drag them around. The order of operations goes from the top down. So just moving one to the top will make it much quicker. So I'm going to speed this up a little bit. And we can see that we're done. looks pretty good. We're a little over aggressive with these countersinks, and we're a little over aggressive with that countersink as well. So what we can simply do is we can go to these countersinks, double click on the operation parameters, and we can override the machining depth a little bit, maybe create a little bit less aggressive of a cut. But that's not something we really worry about. The main thing we wanted to learn in this is just sort of generally what types of operations you will see created from different types of holes, as well as how to reorder and combine features. That's it for this video. Thank you for watching. Next week, what we will be doing is we will be covering more types of machinable features and dealing with a little bit more complicated parts. See you next week.